Okay, so I'm going to pick up where we left off yesterday at my kitchen table, and we are going to start off on page 2 from your packets. So if you take out your packets, look at page 2. We're going to do the first 2 problems together, and we're going to do it on the calculator. Yesterday we had estimated that 47.5% of babies weigh between 7.5 and 8.5 pounds, and 2.5% of people have a IQ higher than 130. So we're going to find out the real values off of the calculator. So in order to use the calculator, there's only 4 values that you need. This is TI Inspire or 83 or 84. The 4 values that you need the lower bound, the upper bound, you need the mean, and I always represent the mean as x bar, but on your calculator it represents it as this Greek symbol mu, which is the mean. And then you need the standard deviation, and on the calculator I think they've got it as S or sigma. I forget which one. We'll find out in just a moment. So the lower bound and upper bounds are the left and right sides of the shaded region. So in this case the lower bound is 7.5, the upper bound is 8.5. The mean for this they said was 7.5, and the standard deviation was 0.5. So when you take out your Inspire, okay, I think you can see that there. Let me just clear all those out. Whoops. So when you take out your Inspire, if you hit the menu button and go down to statistics and then distributions, and you will see something called normalcdf. Normalcdf stands for normal cumulative distribution function. So normalcdf is normal cumulative distribution function. And that's what we're going to be using primarily today. We will be using one other thing. So you can see that there's the 4 items that I represented, and it's sigma that they have here. The 4 items that I listed here, that's what they've got listed here. So literally you're just going to type those in. So I'm going to type in 7.5 tab, 8.5 tab, tab, and 0.5 tab, and when I hit OK, it gives me back a percentage, which that percentage I have to multiply by 100. When I multiply it by 100, I get 47.725. So what I typed into my calculator, and you could actually type this into your calculator as is. In fact, for the people on the 83 and 84, that's what you're going to have inside your calculator. So it's going to be a normal CDF 8.5. Sorry, that would be a 7.5. 7.5, 8.5, 7.5, 0.5. And it comes back, the value was 47.725%, which is very close to the estimate that I had before. So I feel really good about that. So now let's come over to this one. It's going to be, let me just show you on the 83 and 84 super quick. On an 83 and 84, when you do this, oops, that one doesn't work. Please hold. Oops. Okay, so on the 83 and 84, if you hit second and then vars, distribution is right above that, you would do normal CDF, and then you would type in the values that I just had. 7.5, comma 8.5, comma 7.5, comma 0.5. And it gives you back the same value, which you would multiply by 100. So you get the same thing on the 83 and 84. For this one here, for the lower bound, it's the left-hand side of the shaded region, which is 130. The upper bound is the right-hand side. Now in this case, and the standard deviation for this one is 15. The upper bound, notice how it doesn't end, so it ends up being positive infinity. So the way to represent positive infinity on your Inspire, if you go to menu, go back to statistics, distributions, normal cumulative distribution function. When you do that normal cumulative distribution function with the values of 130. Now, positive infinity, the way to represent that here, I'm going to do 9 and then this funny E over here. On the other faceplate, it's also in the lower left-hand corner, this double E, 9E, 999, that's positive infinity. And then I'm going to put in my mean of 100, and I'll tab over to the standard deviation of 15, and tab, and hit OK. And that comes back with 0.22. A lot of people forget to multiply it by 100. So this is 2.27%. So when I do that, I get 2.27%. If you forgot to multiply it by 100, when you compare it to your estimate, you'll know whether you were on target or not. So that's close enough to my estimate that I feel pretty good. So representing positive infinity on your TI 83 and 84, you would still do 130, comma, and then here it's 9, and the double E is right above the comma, 99. And then you would still have the mean and the standard deviation, which I think was 115, and it comes back with the same value. So go ahead and try these two here, and you can check your answers with, or just practice them, and then you can come back over to the sheet. I'll write what you have here. You could pause the video and try these yourself. So here you're going to do a normal CDF, 530, 630, 430, 100, and that comes back with 13.95905. And for this one, it's a normal CDF of 1.8, 5.4, 4.2, 1.2, and this comes back with 81.8595. So you can check your answers with, oh, that's a little bit off the screen there, isn't it? Let's go there. There. So you can check your answers with what I've got right here. Okay, so now what I'm going to have you do is I'm going to have you get rid of pages 5 and 6 out of your packet. You could just cross those out. I'm coming up with a simpler approach for what we're doing here, so just ignore pages 5, 6, and then you can go straight over to page number 7. So this is now page number 7. So here, these were falling exactly on a standard deviation, which made our estimates really accurate. On page 7 now, we're going to be doing the same thing, and what you'll notice is it doesn't fall exactly on a standard deviation. So I'm going to cross this off right here because I'm coming up with my simpler approach. So cross off what we did here. And in this case, I still have the mean of 100 and the standard deviation of 15, but I want the probability of picking an IQ higher than 125. And you'll notice 125 right there is not falling exactly on my standard deviation. If it was 130, then it would be 2.5% approximately. But now it's going to be higher, so I'm going to estimate something higher than 2.5%. So I'm going to estimate like 4%, something like that. So when I do my normal cumulative distribution function, I'm going to put my lower bound of 125, my upper bound of whatever positive infinity happens to be on your calculator. Then I'm going to put my mean of 100 and my standard deviation of 15, and I'll get back about 4.8% from my calculator. So I feel pretty good about that. Now, let's say in this example number 2, let's say I wanted the probability of having a score, an IQ, so the probability that the IQ is less than, let's say that it's less than 85. So actually I'm going to pick a number that's not exactly on a standard deviation. Let's pick, what's the probability that the IQ is less than a 90. So here I'm going to also do a normal CDF. And I'm going to call this 2B, and I'll call this 2A, and this is all for 2A. So I'm going to do a normal cumulative distribution function, but in this case now, my estimate is going to be, let's see, this percent here would be what is that, 16%. So it's going to be a little more than 16%. So my estimate is going to be about 20% for 2b. So on the left bound, I have to use negative infinity. I'll show you how to do that on the calculator. So that's negative infinity, comma, my right bound is 90, my mean is still 100, and my standard deviation is still 15. So I'm going to put that in on my Inspire. So on the Inspire, when I do menu, statistics, distributions, normal cumulative distribution function. Do you notice here, negative infinity is already in the lower bound. So that's negative 9E999. So you can just leave that in there. Your lower bound, if it goes off here, will always be negative infinity. Your upper bound would always be positive infinity. So make sure you don't get those two swapped. So that's negative infinity. And then next is 90. My mean is still 100. And my standard deviation here is 15. And I tab and I hit OK. And I multiply that by 100. And that comes back with 25.24%. Is that right? 25.25%, if I round correctly. So the probability of getting an IQ score of less than 90 is about 25%, which coincides with my estimate pretty closely, so I feel good about that. So that's all well and good. So you should be able to do numbers 1, 3, and 4 right now. So you can pause and do those if you'd like, and then start up the video and I'll show you how to do number 5. So for number 5, here, oh, and let me make one other note. Whether you're using the TI Inspire or the 83 and 84, if you're entering a negative sign, make sure you use this button here for the negative sign. Don't use minus, because if it's negative infinity, you have to use this negative sign, or on the Inspire, use this negative sign. Otherwise, it's just not going to work. All right, so let's take a look at number 5 now. So number 5, you see that? Yeah, I think you can see that. So in number 5, now we're talking about percentiles, which we talked about in class. Again, I want you to just cross this stuff off here. And I apologize. You could print out clean versions of this from my website. That way you don't have this stuff in here. So I want the scores on a standardized test are normally distributed. The mean is 50, standard deviation of 10. So I've drawn my bell curve here. And I want to find the 80th percentile. So I know that the score of 60 is the 84th percentile because 50% of the population falls below a 50 and another 34% falls in this range. So this score of 60 is the 84th percentile. So I know that the score should be somewhere between 50 and 60, probably closer to 60. So that's going to be my estimate. So in order to do this on the calculator, I have to do the inverse function. So I'm going to do this on my TI 83 first. So I will go back over to statistics, distributions. I will choose inverse normal. So now when it says area, that means the area underneath this curve. And if the whole area is 1, we want 80% of the area, which is this number, this percentile. 80 divided by 100 you could put in, or you could just put in 0.8, whichever one works best for you. The mean for this data was a 50, and the standard deviation was a 10. And when I put that in, I end up with a score of 58, which feels really good to me. That seems like the right score to get. So for this, I did an inverse norm of 80 over 100, 50, 10, and it gave me a score of 58.4. I can do the same thing on the 83 and 84. So why do I keep picking up the one that doesn't have the batteries in it? Okay, so here I'll do second distribution. Once I do second distribution, now I'll go over to inverse norm. I'm going to select that. And I will type in 80 divided by 100, comma, 50, comma, 10. and it comes back with the same score of 58.4. So a score of 58.4 represents the 50th percentile. So what you are going to do now is you will continue, so you're going to finish page number 7 in the packet, and you're going to do numbers 1, 3, and 4. I want you to draw a shaded bell curve for each. I want you to come up with an estimate based on what you think the probability is going to be, and then figure out the lower bound, upper bound, and mean and standard deviation, and put that in. So I think you should finish that in the campus center. And then you're going to do the same thing on page 8. This is the homework assignment. It's homework 17.6. For this, you're going to, you could probably just draw one big bell curve for this, 625 with a standard deviation of 40, and then come up with your estimates for each of these ranges, and then actually get the percentages from your calculator. Cross off this column here. You're not going to fill anything out in there. And once you do that, then knowing what you know about percentiles, you're going to continue on here. And these 3 questions are actually related to D, G, and J. So for instance, for D, when I drew my shaded bell curve, I estimated that it was going to be like 1 or 2%. It was going to be a really low percentage. When I did my normal cumulative distribution function, I did that from, what was that? From negative infinity to 525 with a mean of 625 and a standard deviation of 40. And multiply that answer by 100 to get 0.6. So that means 0.6% of the population got a score less than 525. That's what the percentile is here. So theoretically, they're in the 0.6th percentile if they got a score of 525. But we never use decimals when we talk about percentiles, so I would say that they were in the 1st percentile, so I would round that up. So you're going to do the same thing here and here. And number 3 is very similar, so you're going to do something similar. And then for these problems down on the bottom, this is where you're going to use the inverse norm, because you're going to do that reverse lookup where I give you the score, or I give you the percentile, and you have to give me the score back. And that's similar to problem number 5 from page 7. So you can go back and look at the video if you had trouble with that. So finish up page 8 for homework, and we've got a quiz in class the next time we meet. This will not be on the quiz, but we will review this. Because this is definitely on the test. And please help one another out. And I think you should actually be able to finish all this in the campus center. Good luck. See ya.